Hola, yo soy Leyre Catalán, soy profesora en la Universidad Pública de Navarra y voy a inaugurar el ciclo de charlas de JAKIN-MINA 2024-2025 con una charla que he titulado Generar electricidad en la Antártida, la aventura de instalar generadores termoeléctricos en un volcán activo. En esta charla voy a hablar de lo que hemos conseguido gracias a un proyecto de investigación que nos ha permitido ir, el pasado enero, a la Antártida, a instalar por primera vez en el mundo generadores termoeléctricos que transforman el calor de un volcán en electricidad.
Arratsaldeon, buenas tardes. Gaur hasiko da berriro JAKIN-MIN zikloa Iruñan, 2024-2025, ¿vale? Bueno, esta es la nueva edición de JAKIN-MINA-Pamplona del curso 2024-2025. Bost hitzaldi izanen dira, badakizue, eta gaurkoa izanen da lehenengoa. Como comentaba, tenéis 5 conferencias con expertos y hoy será la primera, eta hau izanen da ingelesez. Hurrengoa euskeraz eta hurrengo hiruak gaztelaniaz. Esta primera en inglés, la siguiente en euskera y las 3 últimas serían en castellano. Gaurko ponentea Leyre Catalán Ros da, bai? Ingeniaria da bera, ingenieri industriala, UPNAn egin zuen, Ingeniería Industrial por la Universidad Pública de Navarra, doctoratua ere unibertsitate berean, en la misma universidad también se ha doctorado no sé exactamente en ingeniería industrial, pero más en ingeniería térmica y de fluidos. Eta hor dagoen talde horretan lan egiten du ere bai. Eta irakaslea ere bada unibertsitate publikoan. También es profesora de la Universidad Pública de Navarra. Tiene también otra serie de títulos como máster en Energy Systems en Högskolan. Suediako unibertsitate bat, una universidad de Suecia. Gero, aditu titulua datu zientzian eta big datan, gai berria, en ciencia de datos y big data, hori ere UPNAn egina. Gero, bera bada ere, hau da, Nafarroako energia berriztagarriak sustatzeko elkartearen kidea, forma parte de la Asociación para la Promoción de Energías Renovables de Navarra, eta bada ere, yo soy científica, edo ni zientzialaria naiz, emakumeen artean zientzia ikasgaiak eta sustatzeko, para promocionar la vocación científica entre las mujeres. Yo soy científica, eta bera da aktoresa. Eta azkenik, bera da elektrovolkan proiektuan parte hartu du, ez dakit berak azalduko du agian gehiago zer den hori, interesgarria ematen du. Eta jatorri volkanikoko bero geotermikoa elektrizitate bihurtzen duten prototipo termoeléctricoak garatzen ditu. Bueno, nahiko luzea. En castellano es, en el novedoso proyecto Electrovolcán, en el cual desarrolla prototipos termoeléctricos que conviertan directamente el calor geotérmico de origen volcánico en electricidad. Beraz, bueno, ja bere txanda eta berak hitz eginen dizue. Gero, irekiko dugu tarte bat, nahi baduzue, galderak eta egiteko. Orduan, adi-adi, entzun eta ia gustatzen zaizuen. A ver si os gusta.
Eskerrik asko. Now we have to switch to English. So, as Yolanda has said, my name is Leyre. I'm a teacher at the Public University of Navarre. And I'm going to start these JAKIN-MINA sessions with this talk that it is entitled Generating Electricity in Antarctica, the adventure of installing thermoelectric generators in an active volcano. In this talk, I'm going to talk about how the three of us had the opportunity last January
to go to Antarctica and do some science over there that you will understand a bit later. I'm not going to be super technical, it's more about the experience, but it's also important that you understand the problem and the issue that we are trying to solve, because it's all about, and we have worked really hard in order to make it possible. It's the three of us going to Antarctica, but we belong to the Thermal and Fluids Engineering Research Group. It's a group of about 20 people. We all work at the Public University of Navarre. We are mostly engineers, and basically, well, some are students, other are only researchers, other, as me, are both researchers and teachers. But the idea is that all of us focus on improving thermal systems, and in this case that I'm going to talk today, trying to convert heat into electricity. So we all work in different projects, research projects, as that's how normally science is done. You apply for projects to the different funding entities, for example, the ministry, you get money and you need to solve a problem, and that's what we do. Among all the projects that we develop, the one that has permitted us to go to Antarctica, it's this one. It's funded by the Spanish Ministry of Science and Innovation. And basically, it's trying to develop systems that make volcano surveillance autonomous. This means that you can monitor volcanoes in an autonomous way. This means that you don't, like in places where you don't have a plug, you can still monitor what's going on in a volcano. And why do we want to monitor volcanoes? Here we have two pictures. Maybe you remember that in 2021, La Palma volcano started its eruption. Before the volcano started the eruption, if you remember, all the televisions, all the Spanish televisions were over there, and they even recorded in live the moment where the earth broke and the volcano started erupting. This was possible because the geologists had alerted that the volcano was going to erupt. So they knew that the volcano, like something was happening in La Palma, something was going beneath the earth, something was happening. And they were saying, watch out, it seems that a volcano is going to erupt. And a few days later, televisions were there, everybody was talking about this, and in fact, it happened. La Palma volcano, that now it's called Tago Gigaite, normally it's called also Cumbra Vieja, volcano erupted. Since we knew that the volcano was going to erupt, this permitted, for example, to evacuate some people beforehand, and that's important. This was not possible, for example, in another volcano in Indonesia called Mount Semeru, where, for example, 34 people died. So if you are able to predict if a volcano is going to erupt, that's something really interesting, because you are able to protect people and prevent the risk and the damage that the volcano can occur. Because, I mean, we cannot prevent the volcanoes to erupt, but at least we can reduce the damage that they produce. This is even more important when you realize that 10% of all global population live less than 100 kilometers from a volcano. So 10% of global population, that means 770 million people are in risk because of volcano eruption. However, only 30% of all volcanoes in the world are being monitored. So it's important to monitor volcanoes, but only a few of them are monitored. Which is the problem? Why not all volcanoes are being monitored? The problem is the power supply. If you want to monitor what's happening in a volcano, you need to install sensors in order to see what's going there. For example, you measure how the ground is moving, because the ground beneath a volcano, it's moving, it increases, and it goes like it moves. So if you measure that deformation, you can see what's happening inside the volcano. You can also see if there are temperature difference. If, for example, the ground is hotter, that means that magma, for example, is closer to the surface. Or if you have like some gases going out, that means also that there is some activity. So you want to measure all these things, and you need sensors in order to do it. But these sensors require energy, and you don't have a plug in a volcano. So because the lack of powering, it's why only 30% of the world's active volcanoes are being monitored. How do we normally supply power to the sensors that monitor the state of a volcano? The most typical thing that is used are photovoltaic panels and batteries. So we transform the power of the sun directly into electricity. Since we only have sun during some hours, we also need some batteries. This is a quite good solution in many volcanoes of the world. However, it's not viable in many other places. For example, think in those volcanoes that are quite high, have a relative altitude. They suffer from snow, and the snow covers all the PV panels. If your PV panel is covered with snow, it's not going to generate. You can also think in those volcanoes that are in, for example, Iceland, or those regions with really high latitudes. You don't have sun for months. Like for 3, 4, 5, 6 months, you don't have sun. So if you don't have sun, you are not going to obtain electricity. You can have a really big battery, but taking a really big battery to a remote place, because volcanoes are normally remote, it's not easy, it's going to be expensive, it's going to be super heavy, and that's a problem. So how this project started? It started with electrovolcan project, and what we thought was, okay, you're in a volcano, that it's one of the most evident signs of geothermal heat. So why don't you transform this heat into electricity? You have heat is always going to be there. Transform it into electricity, you are going to have like a continuous source in order to power your sensors. And that's how we started to do research. The first thing is, which is a technology that permits transforming geothermal heat into electricity? And the first answer is a turbine. A turbine is going to be a big machine that it's rotating, and with the rotating movements, it's going to generate electricity. But this means something super big, super expensive, that requires a lot of maintenance, and that it's not a good solution for a volcano. Sensors normally don't consume much energy. I mean, it's like if in order to power a smartphone, you put a super big machine, and that's not possible. You need something small that because you don't require much energy, and the most important thing is that you don't require a lot of maintenance. You need to leave it in a volcano, and so that you have like a permanent power source for your sensors. And we started doing research, and we ended up in this technology that it's called thermoelectricity. Thermoelectricity is based in semiconductors, and basically the idea that you should have is that these devices permit transforming heat into electricity. It's like a PV panel, but instead of working with sun, it works with heat. Okay? It's a really small thing. It's 4 centimeters times 4 centimeters. It's module, and this is like if they have a temperature difference between the sides. Imagine like something like this. If you have a temperature difference, you are going to generate electricity. The greater the temperature difference, the greater the generation. And although this sounds quite strange, like maybe, like probably you have never heard about this, it's not a new technology. In fact, all the probes that NASA sends to the space have this technology. The rovers that are in Mars, Perseverance, Curiosity, or even the probes that are sent longer, for example, Voyager, have this technology. Okay? In space, you also need energy for sensors, and you need a power source that does not require maintenance. And thermoelectricity is going to be the solution. In fact, they have demonstrated that it's a really robust technology. They have been working these generators for more than 40 years in space without any maintenance. So they have demonstrated that their robustness is really good. So it seems that they are also going to be a good solution for volcanoes. Why don't we know about this technology before doing some research? It's because if you compare it with other technologies, the efficiency is super low. So with a available temperature difference, if you put a turbine, you are going to generate much more power than if you install thermoelectric generators. You can improve the efficiency in two different ways. You can improve the materials, and there are some chemists, some material engineers, some physicists that are trying to do research about materials that improve the efficiency. Here we have a graph. We have the efficiency versus the temperature difference. As I have said, the higher the temperature difference, the higher the generation. So that's why you can see that the higher the temperature difference, the higher the efficiency. All these lines are different materials, so materials that some chemists have developed in order to improve this technology. We, like commercial ones, are still these red ones. We have efficiencies less than 10%, so that means that for each unit of energy that you have of heat, like you are going to generate less than 10% of electricity. In our case, we just buy the commercial modules, and what we do is trying to improve the heat transfer. Because I have said before, we belong to the Thermal and Fluence Engineering Research Group, so we are going to work in improving this temperature difference as the efficiency is going to increase. In our case of the volcanoes, we have the volcano that it's hot, we have the environment that it's colder, so that's our temperature difference, and what do we want? We want the hot side of this thermoelectric module to have a temperature that is as similar as possible to the temperature of the ground, and the cold one that has a temperature as close as possible to the environment, so that the temperature difference is the one that it's more similar to the available one. And that's what we do. We did some research about different heat exchangers. I'm not going to enter in this. We ended up with a solution that it's based on phase change heat exchangers. These are like super efficient heat exchangers, and in fact, we patented this technology. That's the technical part. Now you're going to see a lot of pictures. Once we had the idea, that was back in around 2016, I was finishing my master's. The group had already started thinking about this, and then I started my PhD with this. What we did was starting testing this idea in the laboratory. And we realized that it was working really good. But it's not the same working in a laboratory than working on field. It's like volcanoes, like you cannot simulate a volcano in the laboratory. So the next step was going to an active volcano, and we went to the Canary Island, we went to Teide volcano, and we installed in December 2019 this device. We checked that what we thought was actually true, that we could transform the heat from an active volcano into electricity, and we could power some sensors with this device. In fact, it was working for more than 3 years. It was December 2019, so in 2020, COVID pandemic started. We were all like closed in our homes. Not even the geologists could go to the volcano in order to see what was happening, and we could have a connection with the volcano because our sensors were working. The other sensor that the geologists used, that they required going every 2 or 3 weeks to the volcano, lost the connection, and the only information that they have from the volcano was from our devices. We continued improving the technology, and we used another place with different characteristics, and it was Lanzarote. Lanzarote is also in the Canary Island, and in this case, we have really high temperatures. So at Teide volcano, we are talking that we have temperatures of around 80 degrees in the ground. It's hot, but it's not like super, super hot. In Lanzarote, we have temperatures up to 500 degrees. So you put your hand like really close to the ground, and it's really hot. So that's why, since we have a hotter heat source, we can generate more electricity. We did it in several steps, trying like improving different parts. We started with 35 watts in 2 different places, and we ended up with 400 watts installation. If you go to Timanfaya National Park, you can see these devices. And as here you cannot realize how big they are, I have here this picture so that you can realize the size, okay? So the Lanzarote ones, we have really high temperatures, so we can generate more electricity, are like 1 meter high, quite compact. We have something like inside the ground that it's 200 meters deep, but outside it's only 1 meter. In this case, since we have like really high temperatures, we can generate a lot of power, 400 watts. But that's not usual. It's normal is to have temperatures more similar to Teyde's one. Here the prototype is like, it's here. It's 50 centimeters, so super small. Since we have less temperature, we generate less. But the left one, Teyde, is an active volcano. The right one, it's Lanzarote, Timanfaya National Park. This is not an active volcano. This is a place where some magma has remained really close to the surface. And on the right, the idea was to generate as much as possible. That's not the idea of the project. It permitted us to learn a lot about how the heat transfer with the ground is. But for the Antarctica project, what we want is to somehow replicate this, okay? Replicate this, generate from a source that it's around 80 degrees, and that generates enough power to power the sensors that monitor the volcano. So we don't want to generate as much as we can, just enough to power the sensors. That's the objective. And those are the objectives of the project. Okay, improve this technology that you have already started working on. This, as you have seen, it has taken like several years, so we needed to improve the technology, test it in Antarctica, and also if it's viable in Antarctica, that it's one of the most remote places, probably it's going to be easier to replicate it and install it in any volcano of the world. So these are the objectives of our project. And the first question is, okay, why in Antarctica? Because when we think about Antarctica, we think of a place that is super cold, super windy, super like icy, all with snow. And the question is, but do we have volcanoes in Antarctica? We do. We do have some volcanoes in Antarctica because we don't have to forget that Antarctica is a continent. So for example, the Arctic, that it's in the north of the Earth, it's only ice. Below the ice, there's nothing. Like the ice is on the sea. Antarctica, that is in the south, it's a continent. So below the ice, we have mountains, we have like Earth somehow. So the origin of these places can be from volcanic origin, and this is in fact the origin of some islands that are these ones, that it's the South Shetland archipelago that have volcanic origin. So there is a volcanic ridge where the magma ascends and created some of these islands. We went to an island that it's called Deception Island, and if you look to the satellite image of this island, it's this one in the left. And you can see that it's the crater of a volcano. This is an active volcano. It's not the same one, but it's an active volcano, and you can see that the island, it's the crater of a volcano. And when you are there, when you are in that island, you can realize that you are in an active volcano. You are walking over there, and suddenly in the middle, for example, of a beach, there are some gases emerging from the ground. That's called a fumarole. And if you measure the temperature, it's more than 100 degrees Celsius. In fact, if you get like really close, it seems that it's boiling. Well, it doesn't seem, it's boiling, right? It's like when you cook at your home, but like in nature, like because of the volcano, the water, like seawater that's over there, it's boiling. That's really impressive. Then there's, for example, this beach that it's full of fumaroles. The temperature is not that high, it's around 60 degrees, but it's still really impressive because it seems you are like in another planet walking over there. And well, you move around the island and you can measure like different temperatures. In other places we have, for example, 94 degrees Celsius. That it's quite impressive. And since you are in an island, that it's in fact an active volcano, you need to be, you have like some rules that you need to follow. because the last eruption was not that long ago. Maybe for you it's like super long ago. It was like around 1970s. If we talk about a volcano, this is like super close in time, okay? Because like in Earth, the time ranges are like super long. So this is a quite recent eruption in 1967. And since this eruption, for example, destroyed part of the installations that were over there. This was a research station that belonged to Chile and was completely destroyed because of the volcano eruption. And they have left the rest of this building so that you, like, as a resemble of, okay, you're in an active volcano that at any moment can begin its eruption and can destroy whatever you have there. In order to avoid this, there are geologists over there that are monitoring the volcanoes, and every day they have like a traffic light system: green, no risk; yellow, watch out, something is happening; orange and red. And depending on the case, you need to evacuate the island. Okay. In this island, there's only people during 3 months, from December to March. The rest of the year, nobody lives over there. But it's when you go there, you realize that it's an active volcano. When these geologists are over there, they do 2 different things with regarding the volcano. So they want to know how the volcano behaves. So they do this temporal series that they have been doing them for several years. So they know how the movement of the volcano is, how the earthquakes are, how the temperature variations of the ground behave. And in order to do this, what they do is install sensors and measure. But they can only measure when they are there, because these sensors work with batteries. So their job basically is being there for 3 months and going from one side of the island to another, changing batteries. For volcano surveillance, they install even more sensors, like more complex things, and still they don't have like power for the whole year in all the points of the island. So with our device, that, if you remember, transform heat into electricity, the idea is to have like a permanent battery that can power all the sensors that the geologists require in order to contribute to their research and also to volcano surveillance, like to monitor what's going on in the volcano. So that's the objective. We will end up with the device, but so that you can understand how we did it, I'm going to tell you a bit about this. Because going to Antarctica is not as easy as you can think. It's a quite restrictive area, and if you want to do research over there, like, for example, Spain only has 2 research bases over there. You need to do a lot of paperwork and a lot of ask for a lot of permissions in order to go there. So first of all, you need to do a campaign plan. Okay, I want to go to these places in the island, and I want to do, like, each day it's this activity. It's not going to be possible to follow your plan because nature behaves as like randomly. But you need like a plan. Then you need to prepare things. In our case, we needed to develop the devices in the laboratory, check if we have everything. If you are there and you need like a screwdriver and you have not taken it with you, you're not going to have it. So you really need to make sure that you have everything you need, that you have developed everything. And for example, we were here testing different devices with different like thermal things, different variations, in order to see which one was better. We tried some isolation. We even tried how to carry these devices in the island. And we also developed the technology for the sensors that were monitoring what was going on. After that, after you make sure that what you need to carry, you need to put it in boxes. We went to Antarctica in January. We were finishing packing in the beginning of November. So with several months in advance, you need to put like everything in boxes, because these boxes are going to travel by boat during several months until they reach Antarctica. You also need to follow strict rules. There are some universal protocols in Antarctica in order to, because Antarctica is like governments want to keep, like, it doesn't belong to any government. It belongs to everybody. It's like, and there is a protocol, a lot of protocols in order to protect it. Like, the idea is to have it as a huge natural laboratory, and like, for example, you cannot build anything over there. Everything that you put in Antarctica, afterwards, it's necessary that it's possible to take it away. Like, nothing can remain there. Every rubbish that you generate, you need to take it with you. So there are a lot of protocols that you need to follow. So you need to have a special formation, and we went to the ministry in Madrid, and we had some talks about that. We also had some strict medical controls. For example, you need some vaccines, but it's very strict. They do a complete check in order to prevent that something happens to you in Antarctica, because you don't have hospitals over there. So it's important to have like medical checks, also some laboratory situation, some rules that you need to follow, some permissions, because even like inside Antarctica, you need also special permissions until you have the official permission. We obtained it in December 2023, and we were going there in beginning in 2024. It was, I think, 7th of January, around that. And you can see the pictures. The three of us, we were really excited about going to live this experience, a lifetime experience. So we had to take clothes, not many because you don't have a lot of space there, put them in a small bag, and then start traveling to reach Antarctica. That it's going to be a quite long trip, as you will see. First step was traveling from Pamplona to Madrid. And when we arrived to Madrid, we discovered that our next flight was canceled. First, bad thing in our trip, but we said that's going to be the only bad thing that happens to us in the trip. So we slept in Madrid, and next day we could travel to Santiago de Chile. And from Santiago de Chile, we took another flight to Punta Arenas, that it's in the south of Chile. Okay? The only 2 points where you can travel to Antarctica is Punta Arenas in Chile or Ushuaia in Argentina. In our case, it was from Punta Arenas. We arrived there 2 or 3 days later, I don't remember, and we were completely exhausted. We could see Punta Arenas, and the tradition says that if you are going to Antarctica and you want to be lucky, you need to touch the foot of that Indian monument. So that's what we did. We were quite excited. We were really close to Antarctica. Everything resembled us to our devices, as this over here. But there we had still a step to have. We needed a negative COVID test. If you are positive in COVID test, you cannot travel to Antarctica. We had it. Also, the weather was good, because that's also something that it's necessary. So next day, we could take another plane and fly from Punta Arenas to King George Island. In our case, we did it by plane, but some other researchers do this by boat. If you go by boat, it's 3 days by boat with waves of more than 10 meters high. It's like super dizzy, like people are 3 days vomiting, because it's a bit awful. In our case, we were quite lucky, and we could take a flight to King George Island. And in the flight, we started realizing that we were going to Antarctica, seeing the first icebergs that are quite impressive. Landing in this island, it's also impressive. And it's because since you cannot build anything, as I have said before, you don't have like a road where the plane lands. So it lands in rocks. So that's quite impressive as well. And you need like really good visibility in order to be able to land there. That's why the weather needs to be like super good. We were in King George Island, but that was not our final destination. We had to go to Deception Island, and for that we needed to take a boat. In our case, it was the boat of the Bulgarian army, because there is a lot of international cooperation in Antarctica. It takes around 10 hours to go from King George Island to Deception Island, but in our case it took us 2 days, because the weather was not good, the sea didn't have like good conditions, so we stayed in the boat for longer than expected. The sea over there is quite cold. If you fall, you remain with your your consciousness remains good for only 15 minutes. So that's why every time you are going to go by boat, you need to wear these suits. They are called surveillance suits. Basically, it's if you fall into the sea, you are going to survive because they are going to keep you warm. You only wear them from the beach to the boat. That the boat was over here, but you are taking a small boat to go up the big one. So you have to these safety suits in order to go to there, and you look like Bob Esponja, and it's quite funny. During our trip, we could realize that now we are in Antarctica. We could see the iceberg closer. We could see these landscapes that are typical from Antarctica. But we also realized that in some islands there was almost no ice. For example, in this one. And it's because it's a volcanic island, it's hot, and if it snows, the snow melts because the ground is hot. We could also see some penguins. This ice has a lot of black points. Those are penguins. We could also see whales, and we were realizing that we were over there. More when we realized that in some places the sea was frozen. This was when we had to go from the big boat to our final base, and now we have some videos. So these are the small boats called Zodiacs, where it's how you move. You disembark, in this case, with this frozen sea. And these were our colleagues going to the other Spanish base, that it's called Juan Carlos I. That was not our base. Our base, it's called Gabriel de Castilla. That was on Deception Island. So after more or less 1 week, we arrived. This is the base. It's made of containers, because as I have said, you need to be able to remove everything you install over there. And the green big container that is in the middle, it's called the living container. It's where you sleep, where you have the bathrooms, where you have the living room, where you have lunch, have dinner. The rest, some are workshops, others are for research, others are containers for the rubbish. You have several things. In other, you have storage for the life suits, all these things. If you look inside at it, people normally ask us how it's life over there. So we had this small living room. We had dinner, breakfast, lunch, and dinner in these tables. Shared rooms with these young beds. And for example, one container was a gym in order to keep good shape. Our routine over there was mostly every day similar. It didn't matter if it was Monday or Sunday or Saturday. Every day the same. Waking up at around 7, breakfast at 7:20, and at 8 start working. We worked until 2:30, and then in the afternoon from 3:30 to 7:50 when there was a very important meeting, that it was the meteor report. So people from IMET also go to Antarctica, and every day they do a meteor report in order to people be able to know what's going to happen. So here you have the meteor report. Javi, that was the guy from IMET, was in the other base, in the other island. That's why we connected with him by online meeting. And what he basically told us about the weather the next day, and he did something like this with this yellow, orange, or red risk alarms in order to see what you can do. Because maybe you want, the next day, you want to go to a part of the island, but if the weather is not good, you cannot go by boat, it's going to be snowing, it's going to be super windy, and you cannot go. So all the activities are restricted by the material that you have. So depending on the weather, you can do something or you cannot do it. And that's why this meeting was really important. After this meeting, there was a coordination one in order to say, like, all the researchers that were there were telling, okay, we want to do this, we want to do this, and you like share the facilities and the people over there, because in this case, like, you have people helping you. In this base, it's from the army, like Ejército de Tierra. In the other one, it's civil people, but you have like some support in order to develop your activities, but the support is limited. Like only, for example, 3, 4, 5 people can go with you, and if everybody require help, you need to like share the help, and that's why that coordination meeting was important. Then 8:30 the dinner, and at 11 we went to sleep. It was also important the tides of the island, because movements were usually done by these small boats, so the tides were also important. And since you are living all together, also you need to 1 or 2 days clean for, like, serve and clean for the others, and that's one of your days over there. Regarding science and the project that I have started talking about you, in the island, that it's this one, most of our time we spent it in the base. There we had our workshop in order to manufacture the devices. That's where we lived. But we wanted to install it over the island. So what we did was measure those hot places of the island that the geologists have already told us about, but we needed to characterize them. There were 4 around the island, and in 2 of them we installed some devices. Okay? So in Caliente Hill and Pendulum Cove, we installed a device. But we needed to build those devices. So this is our first day in Antarctica. It was snowing. Our boxes with all the materials had arrived by boat, like with several months in advance, and we needed a place to work and a place to assemble our devices. So we were assigned this container, and our first task was transform this empty container in a place where we could work and we could assemble our devices. So here we have like a time lapse. We use the boxes and we use some wood that was over there in order to construct a table where we were going to work the rest of the days. And this is us after the work completed. Next, we used this place in order to build the devices. So we had taken each piece of the generators and we needed to assemble them because we wanted to protect them from the trip. They go by boat with really like high waves. So what we did was protect every part and then assemble everything when we were there. So that you can have a better look of what we were doing, these are the devices. So these tubes is what goes inside the earth. They are going to absorb the heat. Here we have those thermoelectric generators that transform the heat into electricity, and the heat that is not transformed into electricity needs to be released to the environment, and that's why we have this. These boxes are for protection. You have really harsh conditions over there, too, so you need to protect everything really good. We also were thinking about the structure, and that's what we did. There was also some work to be done regarding the electronics, so we also prepared everything on the base, just like putting and preparing all the sensors that we were going to use. And while we were assembling the prototypes, we went also to measure the device in order to see where we were going to install them. And the first place that we discovered was that one, that it's Fumarole Bay. I'm going to put the video again, and that's the femur that we have seen in the other slide. And it's quite impressive, like in the middle of the sea, some vapor going up. You measure 103 degrees Celsius, and this is where it's boiling. This was the hottest place that we discovered in the island, but it's not a good place for our device because it has a rock. And also you have the sea over there that is going to to make wet your devices. So this is not a good place, but really close to this you have Caliente Hill. So it's a hill, you are up, you don't have that problem. And over there we realized that there was a quite big area with a lot of fumaroles, with really hot ground. We had here a thermal camera, so we could see the hottest places. And finally we decided that our devices were going to be installed in this fumarole that had a temperature of 94 degrees. The fumarole measures 40 times 60 centimeters, and depending when you measure, the temperature is 70 to 94 degrees. And also, these were going to be our views for the next days. You can see that in some places we do have snow. So we had decided that we were going to install the device over there. Next step was taking it with us. First thing was the structure that was going to hold our devices. So it was quite heavy, so we asked for help from the army, and they took us in this small boat, and then we went upwards with the structure until we installed it in the fumarole. The devices, the generators, were more sensible. We didn't want to go by boat because you have a lot of movement. They were more critical, so we packed them in our bags and we walked over there. It was like more or less 1 hour walking, and we took them, like you can see that they are really well protected. We walked over there until we could install them in this fumarole. So you can see that we had made a hole over there, and temperature was around 94 degrees, and we installed the devices over there. Here we have the time lapse, or the installation of the devices, and you can see it was cold, okay? It was January, it was summer over there. Temperature was between -5 and 5, that for Antarctica is not that cold, but the feeling was like quite cold. You can see our faces that we were feeling quite cold with a lot of layers, and we were still feeling cold. And at the end, this was the result. And as you can see, it's quite similar to the one that we had designed in Pamplona. Like we had designed it with the computer. And it's not that big. Like when you just look this picture, it may seem it's quite big. But if you see it with us, and I'm not that tall, it's quite small. It's even smaller than the Teide one. It's like 35 centimeters only. That was the device that generates electricity from the ground, but we also have a part of the electronics. So another day, we took the electronics with us. Basically, we want to control the operation point, also measure some things, and emit the information so that we can see it from anywhere in the world. And this is the example that the meteor report was really important. We were, like Javi told us, that this day, the afternoon was going to be super sunny. So we decided it was a good day for the electronics, because you need to, the wiring is like, you need to do it like it's super small, and it's better if you have good weather. But suddenly it started to snow quite hard, like quite heavily. So we needed to leave and leave the electronics without finishing, because the weather was not good. So the report in this case was not accurate. But we needed to go back another day, and after everything we could install the devices, and we realized that they were working quite good. So that you have an idea of how much we were generating, it's the equivalent of charging the battery of a car, well, in 2 days. So each day you charge half the battery of a car. Okay, that's the energy that we were generating. And here in this image is what we see in real-time monitoring, what we can see in our mobile phones and anywhere in the world. And since we realized it was working, it was time to celebrate the success. It was just working over there, but we were really happy because it was the first time in the world that this was occurring here in Antarctica. This is quite unique. We were there, so we also wanted to see other places where these devices could be installed, and we traveled to the other part of the island, in order to see the anomalies that are at Pendulum Cove and Mount Pond, okay, in the other part of the island. The Mount Pond is the highest point in the island, of the island. We had to wake up at around 4 in the morning. This is 4 in the morning. You can see it's super sunny. It's because we had like 22 hours of light. It's summer over there. This was 4 in the morning. And we started going up to that mountain. This one was quite with a lot of snow. But suddenly, what was impressive is that between all that snow, suddenly there were parts where snow was melted. And if you measure those parts, you could realize that it was fumaroles because it was around 60, 70 degrees, and that's why the snow was melting. There were even bigger areas as this one, where we measured temperatures up to 84 degrees Celsius. That is quite impressive. You are surrounded by snow, and suddenly an area without anything. So it's easy to see where you have this heat. And there is an alternative in order to see if you have heat in the ground. And it's if you see these small green molds, they only grow where you have heat. So if you see these things, this is a protected species, and it's also important not to put your feet on them because they are protected. Since we are in the highest mountain of the island, we also decided it was worth it to go to the peak. And in our way over there, let me repeat the video, we found this ice structure. It was like around 3 meters high, really impressive. And it was shaped because of the vapor of the fumaroles. It was going up to the mountain. It was quite cold. It froze. It freeze. So it created this ice formation that it was quite impressive. We had woken up like really early in the morning because we only have like a small window in order to go there. The weather was going to get worse during the day, and in fact it happened when we were in the peak. This is the picture where we had reached the top of the mountain. We cannot see anything. It's because the weather was getting worse and worse. It was quite cold. You can see here my braces are completely frozen, and it's because it was quite cold. We didn't install any prototype over here, like in this place, but this February, part of the team is going back again to Antarctica, and this time we are going to install a device over there because it's an interesting place for geologists, but now they cannot monitor it because it's super remote, and you can only go there in really specific days when the weather is good. So the next campaign, my colleagues are going to install a device over there. The last place that we discovered with fumaroles is this Pendulum Cove that I have already mentioned. It's this beach full of fumaroles that it seems you are walking on another planet. And we measured temperatures of around 40 degrees outside the sea, and we went inside the sea. We measured temperatures of around 60 and 70 degrees. And you are in the middle of the sea. That's like super impressive. 45 degrees outside, around 60 in the sea. So we have taken with us more prototypes than the one that we were going to install in Caliente Hill, because we didn't know what was going to happen during the trip. So we had extra material, and we decided that it was worth it to test it in this place. So since we had time, we decided to install one device over here. So we digged in the sand, we installed the device. You can see, and it's the time lapse, but you can see the fumaroles. It's vapor going from the ground, and it's because it's quite hot. If you were feeling cold, you just needed to put your feet inside that thing, and it was like around 60 degrees. So it was like a good way to get warm. Okay, this was how we were putting the device, and we put it in a place where the tide was going to cover it. so that we could see what was happening when we had air outside and we had the sea outside. Because the best places for the device were inside the sea. It was hotter. So we did that, and this is the first generator that it was in an intertidal place, and it was actually covered by the sea when the tide went up. We left it for a couple of days. It worked successfully, but we didn't have the permission to leave it like the whole year, so we removed it after 2 days. But in fact, this is the picture that has been more famous. Like every time we appear in the news after the Antarctica trip, it's this picture with the device, this intertidal generator that we have over there. But our main one was the other one, but the famous one now is this one. We remove it. The other one, it's already there, and it's still there. We will see what's going on with it during this campaign. We spent there 18 days in the base. Once we had reached the base, there you have the places that we have gone, the days that we went to, and also how the weather can change. Like from the morning to the afternoon, like you can have a super sunny morning and then like windy, stormy, snowy afternoon, or like that's why it's super important, the weather report. And as a summary, I can say that it was such an intense experience. We were there like 18 days. It seemed like 3 months. Like every day is super intense, but we all feel like super like proud to have had the opportunity to be in there, to live in a place that like very few people can go, where you have like really beautiful views with glaciers that you are not used to them. You also see some animals that are not common. You are surrounded by penguins, marine elephants, lions, seals, no? Those animals that are not normally seen. But after all, it was worth it. It was a really beautiful experience, unique. And this picture over here is from our last day. We were leaving the base, that it's in the back. And you can see that we looked super tired because we were super tired, but we were super happy because we have achieved something unique. Like it was the first time that electricity was being generated in Antarctica, transforming the heat from a volcano into electricity, and the scientific community had a lot of interest on it. It was the first time, and the question is it still working? No, it's not working. It worked for several months, but this summer, like around July, August, we lost the connection. And what I want to transmit is that this is not a failure. Like, it was the first time that we were going there. We didn't know about the conditions, and it has been working for months. That's a first step in what we are doing. But we are doing research. So this was the first step. We have learned a lot of things, and the idea is to go back there, improve the things, and that's what science and research is about, learning about your failures and improving the things. So we lost the connection. This is what we were seeing, but we hope that with all we have learned, next year last at least the whole year, so that the geologists obtain this data for the first time during the whole year, not only during 3 months. If it works in Antarctica, the idea is to be able to extrapolate it to other places and volcanoes of the world, and let's see where this technology takes us. And that was all. As I have said before, we belong to the Thermal and Fluids Engineering Research Group, and the acronym is ITF. So what we normally do everywhere that we go is doing this ITF with every opportunity we have. And you can see, and that's a way to thank the team, because it was the 3 of us going there. But of course, in order to be able to go there and develop all these things, there is a big team behind us, and it's also a way to say thank you to them and to tell them, okay, we are we have you in our minds, and thank you for all your effort as well. So this was all. If you have any question now, you can ask them. If you don't want to talk in English, you can speak in Spanish. Doesn't matter. But yes, I'm going to ask, if you have a question, please raise your hand, because they have a microphone that are going to use so that the recording takes it as well, okay? So anything about the experience, about anything, okay?
Bye. ¿Alguna pregunta? Bueno, le damos un aplauso que ha estado muy interesante y muy intenso. Bueno, alguien, si se quiere animar a comentar algo, a decir.
Ahí tenemos una pregunta ahí.
¿Vais a volver a ir en algún momento? Eso, o sea, ¿está planeado?
Sí, o sea, el proyecto en sí dura 3 años, hemos ido la primera vez y ahora en febrero van a ir otras 3 personas, de los 3 solo repite uno, van otras 2 personas y se vuelve y van a instalar más dispositivos allí. Van a aumentar los que hay y alimentar equipos reales de vigilancia volcánica e incluso ponerlo en más sitios de la isla donde no pueden. Así que en febrero de este año estarán como todo el mes allí en el resto del equipo. La idea es seguir pidiendo proyectos, al menos uno más, e iremos yo creo que otras 2 veces más. Y luego ya pues intentar ir a otros sitios, o sea, una vez que ya lo has solucionado, pues intentar replicarlo en otros volcanes del mundo. ¿Más preguntas? Pues nada, gracias por venir, agradeceros, ¿no? También un viernes a la tarde que hayáis venido hasta aquí a escucharme, encima de una charla en inglés, y que ya veréis como también nos quedan 4 charlas que seguro que son súper interesantes, diferentes, temáticas diferentes, ¿no? Esa es la idea también un poco de estas jornadas, para que aprendáis de cosas, ¿no? Y pues bueno, os surja un poquillo la curiosidad. Y que tal y como estáis, también transmitís el mensaje que es normal que no sepáis qué estudiar, o sea, si alguien lo tiene claro, genial. Si alguien no lo tiene claro, que es lo más normal del mundo, yo a vuestra edad tampoco sabía qué iba a hacer. Yo hice, por ejemplo, una ingeniería industrial porque dije, es una ingeniería bastante genérica y en ningún momento pensé que me iba a abrir las puertas a ir a la Antártida, ¿sabes? Es algo que ni siquiera cuando estaba estudiando el grado, el máster, lo pensaba. Pero cuando estaba terminando el máster me ofrecieron el proyecto y ya ir a Canarias era la bomba. Pues bueno, al final he podido ir a la Antártida, ha sido una oportunidad única. Pero bueno, tampoco tengáis miedo de equivocaros, lo que os he dicho. Este dispositivo pues nos ha durado unos meses. El Teide funcionó años, unos meses. No es un fallo, es un aprendizaje, ¿vale? Hemos aprendido mucho de esto, se va a volver el año que viene. Y esto es investigación, es así, es aprender. Solo que en el laboratorio pues puedes hacerlo más seguido. Aquí tienes la oportunidad de ir a la Antártida una vez al año, porque se va de diciembre a marzo. Así que tienes que aprovechar al máximo la estancia y aprender todo lo que puedas de allí. ¿No ha funcionado? Veremos qué pasa este año. Esa es un poco también el mensaje. Así que no tengáis miedo de equivocaros, aprender. No sé, es que hay mucha gente que, no sé, estudia enfermería y luego se pasa a ingeniería. No tengáis miedo por equivocaros. Simplemente hacer algo que os guste, porque al final dedicas muchas horas de tu tiempo a hacer algo que te guste, y si te gusta lo vas a hacer con ganas, ¿no? Es hacer las cosas que te gustan. Así que os animo a eso, y ya con eso ya me callo y termino.
Bueno, eskerrik asko.